Hello and welcome to Module 4 in our Python series. As mentioned here on screen, we will be looking at list methods today. We've already worked with lists, right? We've looked at the append method, but there are many more methods we need to learn and understand, and we'll do that. We'll then talk about tuples and cement our understanding of tuples and also the difference between tuples and lists. And finally, we will work on our first Python project, which is a simple game. So let's begin with the list methods, and the first one is extend. And I'm going to go straight to the Python shell in order to illustrate these methods. So the first one is extend, like I said, so I could have L1 equal to, and then I could have another list, and then I could use the extend method to do something like this: L1 dot extend L2. Okay, now let's try something. Let's put a variable there, and let's see what that returns. Okay, press enter. If we look at var, there's nothing there, so there's no return value. L1 will have the combination of list1 and list2. Okay, so that's about the extend method. We then have the insert method, which will allow us to insert an element at a particular position. So I could say L1 dot insert 1. Remember, the first position is 0. And now if I look at L1, and again remember the insert has no return value, right? Or we would have seen it here. If I look at L1 though, you can see that my element has been inserted. That's the insert method. The remove method also has no return value. So we can do something like this: var1 equal to L1 dot remove, and we need to specify the name. So let's take the one we just added, and if you look at L1 now, that element has been removed. If we look at var1, there's nothing, so there's no return value. Coming to pop, if I just say L1 dot pop, right, it's going to remove the last element in the list. But watch what happens when I put in a variable there. So if I say var equal to L1 dot pop, press enter, what's in var? And we have a return value, right, the last element. Okay, so pop, remember, can be used by itself, or we could specify an index here. So I could say var1 equal to L1 dot pop, okay, 2. Okay, and then var1 would contain the second, or rather the element at the second index. Remember, this is 0th index, first and second. Moving on, we have reverse, right? So reverse will of course reverse the list. So currently we have L1 like this, right? If I say L1 dot reverse, okay, again there's no return value here. Look at L1 and you'll see that the list has been reversed, right? Okay, moving on, we have sort. Now we have looked at sorted earlier, right? Sorted allows us to store our sorted list, right? So equal to sorted and then L1, right? And then if we look at sorted list, right? Then, sorry, if we look at sorted list, right, then we have the elements, right, properly sorted, as you can see. But we do have our original list as well. So if I said L1, then you would see the unsorted list. So we would use sorted when we needed to retain the original unsorted list. Sort, on the other hand, will sort in place. So I could say L1 dot sort. Okay, again there's no return value there, but you will see that it's being sorted in place. Okay, of course I don't have the unordered list. Moving on, we have index. Let me just expand this now. So index, right, I could get the index of a particular element, right? So let's say L1 dot index of Maltese. Okay, you tell me the index is 2, right? What's the next method? Clear will clear a list. So I still have L2, do I? Yes, I don't need it. L2 dot clear. Okay, again there's no return value, but I have an empty list, right? It's being cleared of all its contents. Then we've got del, and with del we can do something like this. Del, let's look at the list first. So L1, so let's say del L1 of 0. Note how we are using the subscript. Okay, and then if we look at L1, you will see that that element has been removed. So remember, with remove, the method, that is, we need to specify the name of the element, right? With del, we need to specify the subscript, right? With pop, we have a choice of just using pop on its own, which would pop the, how should I say, the last on the list, right? And we could use pop with an index, which would pop the element at the index specified. Next, we have L strip, R strip, and strip. We're going to do all those together. So what I'm going to do here is I'm going to insert spaces. For this one, we'll have spaces both on the left and the right. And for this one, we'll have spaces on the right. Right? And then this one, we'll have spaces on the left. Okay. Now, when you get data, it could be something like this, right? Where you have spaces or things like that. So if I wanted to, for example, use the next method, which is count, right? After R strip and strip, if I said L1 dot count and I needed the number of Maltese in the list, I would get a 0. Why? Because there's so many spaces. So we need to remove those. So we have L strip, right? And L strip works like this, right? I would say for X in L1, right? X dot L strip. So all leading spaces will be removed. Okay, as you can see, there's no leading spaces. Trailing spaces are still there, right? For removing the trailing spaces, I would use R strip. So I would say for X in L1, right? X dot R strip. And then you can see now we have the leading spaces, but the trailing spaces are being removed. To remove both, I would use strip for x in L1, x dot strip. And now both leading and trailing spaces have been removed, right? But if I look at L1, I still have those spaces, which brings us now to what is called list comprehension. So we could do something like this. We could say stripped list equal to, we specify that this is going to be a list that is returned, and then we can say x dot strip for x in L1. And then what happens is stripped list will have the elements with all spaces removed. Now there's one more thing we can do with list comprehension, and that's something like this. We can use list comprehension along with arithmetic operations. So let's say, for example, we need to create a list, okay, with the squares of all numbers from 1 to 10. So we need to create first of all a list 1, right? And then we would say for x in range 1, 10. What happens if I just specify 10? Then the count will start from 0, not 1. And we would say list 1 dot append x raised to 2. Right? Now what would list 1 contain? And you can see the squares. Now I could use list comprehension to create the same list, that is a list of squares. I could say squares list equal to x raised to 2. That's our operation specified first. That's how list comprehension works. You specify the operation for x in range 10. Okay. And then you will see that squares list has got the same result. And the amount of code we need to write is much less. Okay, just one line, right? So that's how we can use arithmetic operations. Now, what if we had a list like this? Let's say we had numbers equal to, say we had negative numbers, right? And we had positive numbers. Okay. And now we wanted only the positive numbers. So what will we do? We could say positives equal to x for x in numbers if x greater than equal to 0. Okay, then if we looked at pos, we would have only the positive numbers. Similarly, maybe we wanted the absolute value of all these numbers, right? So we could do that as well. We could say absolute values, right, equal to ABS Remember this method we did last time of x for x in numbers. And then if we looked at absolute value, we would have the absolute values of all the elements. Okay, so this is about list comprehension. It's important for you to understand because we'll be using this quite a bit. So now let's say I give you one more example or one more exercise in list comprehension. What if we had to create a list of tuples, for example, with the number and the square of the number in the range 1 to 10? So we could use list comprehension for that. How would we do it? We could say x, specify that it's going to be a tuple, x raised to 2, okay, for x in range 10. And what will this give us? You can see now we've got these, right? And you can see these are tuples. Okay. Now, let's just summarize list comprehension. List comprehension provides a concise way to create lists. We saw that. Makes a new list where each element is a result of some operations applied. Okay, which leads us now to our discussion on two-dimensional arrays. Why? Because when we're talking about two-dimensional arrays, we will need to initialize these arrays. Now remember, in Python there's no concept of arrays as such. They're referred to as lists. We call it a two-dimensional list. So all this time we've seen a list of one dimension, right? How do we know that? Because each element is referenced by one index. But in a two-dim list, each element would be referred to by two of those. We would need the row index and the column index. Right, so as is specified here, the first element would have row 0, column 0. The second one, row 0, column 1, that's in the same row, right? And so on and so forth. Similarly, here we would have row 1, column 0, row 1, column 1, row 1, column 2, and so on. Then you would have row 2, column 0, row 2, column 1, and so on and so forth. Okay, so I hope you get the idea. It's just like a grid. Now, how would we initialize a two-dimensional list? Right? Let's assume that we didn't have the concept of list comprehension. Right? So then we would have to do something like this. We would have to first of all initialize a list. Okay? And then for x in range, let's say we want 5 rows, okay, and then we would say row equal to, so there we are creating another empty list, and then we'll say here for y in range 8, we want 8 columns, right? And here we'll say row dot append 0. So in effect, this is going to run 8 times, so there will be 8 zeros in this row, and then we move to the next row, right? I hope you're understanding this. Any queries you have, don't hesitate to post in the comments. I'll get back to you as soon as I can. Right? Now, once we've done that, at the end of this, what do we say? We say list 1 dot append row. Okay, so after this is completed 8 times, we'll append that row to this list. And then of course we'll go to the next row. Okay, so now that list is ready, but of course we want to see how it looks. So we could do something like this, for x in range 5, and then for y in range 8, right? We could say here print, and now we'll have to use two subscripts. So list 1 of x, that's the first subscript, which is the row and the column. Okay, and then here we could have a print to go to the next line, or print the next row. Okay, now let's see what happens. You see, I've got it vertically. What if I just wanted it horizontally? That's easy. I would say here for x in range 5, then for y in range 8, and then I would say print, and remember end equal to, and I could have a space between each of the elements. Okay, and then I could say just the blank print, right? Now you see that looks much nicer, right? Exactly like I would expect it to. Okay, so I have 8 columns and I have 5 rows. So now using list comprehension, right? This is going to be very simple. So what we'll say is list 2 equal to, we open 2 box brackets, 0, 4, we specify the column first. So call in range 8. Okay, we want 8 columns. Close that, and then for row in range 5, and that's all. And then of course we can use the same print or the same logic for printing as we did earlier. So for x in range 5, right, for y in range 8, we say print list 2, and of course we use 2 subscripts, comma, end equal to space. Okay, and then the blank print statement. Go to the next line, press enter, and you see I get the same result. But I can initialize that list in 1 line. That's 1 line of code. Okay. Now coming to tuples. A tuple consists of a number of values separated by commas. We've seen this before, right? Tuples are immutable, meaning that we cannot append to tuples, right? We cannot change them. Okay. Then a tuple with 1 item is constructed by following a value with a comma. It is not sufficient to enclose a single value in parentheses. Now this is important. So if we go to the shell, right, if I say something like this, a equal to 7, right, and then I say type of a, Python will tell me it's class integer. But let's say now I say b equal to 7, and I put in a comma there, right? And if I say type of B, then it tell me it's a tuple, right? So the next point follows from that one where it says commas are responsible for creating tuples, not parentheses. Okay. One important point with regard to tuples is that they are considered to be more efficient with regard to memory. Why? Because if we talk about lists, Python will reserve an extra memory block just in case we append to the list, right? We can append to lists. But since we cannot append to tuples, Python does not reserve that memory block. And that makes tuples more memory efficient. Okay. Now moving on, we start with our first Python project. Write an algorithm to create the game of buzz where the user plays against the computer. This is how the game goes. The user selects a number between 2 and 16. User and computer start the number times table. So here's an example. Taking the 5 times table, the user starts with 1. The computer will type 2. The user types 3, computer 4. And then when they reach a multiple of 5, both user or computer, if it is their turn, that is, must type in buzz. If not, it's the end of the round and a new game can begin if the user so wishes. Right? So now just to give you a visual of how this will work, user types 1, computer 2, user 3, computer 4, user should say buzz or type in buzz. Right? If not, the game is over. Computer type 6, user 7, computer 8, user 9, computer buzz. So something like this. Now about the logic. So whenever we are solving any problem, right, or whenever we are developing any algorithm for that matter, we need to break the problem down into smaller tasks, right? And then have each task assigned to one function. So here, for example, we have the main function, which is game of buzz, and we'll be calling these different functions from that main function. Okay. So this one, for example, will only have the printing of instructions, right? Basically giving the instructions to the user. Choosing a number will focus on allowing the user to select a number, and so on and so forth. Okay. I have put in these functions. So you can do the same. Now pass is very useful when you as a developer, right, need to show what you've done to your client and you haven't really put in code into all functions. Then you can just put in pass so that you don't get errors. Because if you don't put in pass, Python is going to tell you that it expects something here. Okay. So now, as I said, all these functions will be called from this main function. Now, in instructions, what will we have? So we can now remove this pass. Okay, and in instructions, we're just going to have print statements. So the print statements are going to be all in caps, right? So now we put in the instructions function. Right, so from your instructions will be called and this will run. You can actually check now whether this runs as desired. Okay, so you can just click on run module. You need to save it, of course, and then you can just type in game of buzz and you can see our instructions there. Okay, so that works fine. The next thing we'll do is put in the code for choose a number. Remember, the number has to be between 2 and 16, right? So what we do here is we just put in a loop while, and we use an eternal loop here, but we need to make sure that we exit this loop or the machine will go into a hang. Now, how do we ask the user to input a number? Let me take you back to the shell just for a bit. So if we need the user to input something, let's say you want the user to input their name equal to input, enter your name, okay, then you will see the prompt along with the cursor waiting there. So I can type in something, right? And now if I look at name, I will see the contents. Now what if I want the user to enter a number? Right, so I can say number equal to input, enter a number, right? And again we have the prompt with the cursor waiting. I'll enter a number. Now when I look at number, the contents are of string type. And that's important to keep in mind. So now we're asking the user to enter a number, right? So we give the user a message here. Let's say number equal to, and we say input here. And the message will be, then we need to check, right? So if, now we need to use int of number, right, less than 2, or int of number greater than 16, right? And we'll give the user a message saying print. So that'll be the message if the user enters a number which is not between 2 and 16. If the user enters a number between 2 and 16, which will be an else there, else what do? We can print the number chosen is, leave a space there, comma, number. And now we can return that number. But we need to break out of this loop, right? So break out of the loop. And remember, the indentation now has to be in line with that while. So return. Return what? We need to return that number. Now if you're returning this number, then here we will say chosen number equal to choose a number. Now we can see if this runs. So let's run this now. Choose a number between 2 and 16. Let's test it out. Let's enter 1. It says the number must be chosen. The number chosen must be between 2 and 16 only. Let's try 17. Again, we get the same message. Let's try 4. And we get the message number chosen is 4. Okay, so that's running fine. What's the next thing we have to do? Check buzz. Right? So this is, we're checking the user's entry. Okay, so if the user types in a buzz, but of course before that we need to get an entry from the user, right? So we can first of all say here the computer is going to kick off. So computer play, and we could define that here somewhere. So df computer play, and what are we doing in that? So the computer will print or give a message to the user saying, right? And now remember, when the computer is playing, we just need a kind of a counter, right? So what we can do here is, after instructions, we can have a counter there, counter equal to 0, right? And we could have this all in a loop, which will continue as long as the user wants to play. So let's keep another variable, reply equal to yes, and now we have a while loop. While reply dot lower equal to yes. Now of course we have to indent all this. Control X, right? And then bring it to the point where the indent is required. Control V. Now of course you have to make sure that all lines of code are properly indented as is required by Python. If you just press your delete key here, for example, right, so your cursor is positioned here, press the delete key, you'll have your line brought up. Okay, so now all this will run in a loop as long as the user wants to continue. Now my question is, should this be within the loop or outside the loop? Let's leave it within the loop for now. We'll see what to do later on. Okay, now coming back to computer play, like I said, when the computer plays, right, it's dependent on this counter. Correct? So what we do here is we'll increase counter by 1. But can we just use counter? Because remember, counter is in this function. So we need to pass it to the computer play function. So we'll send it along there, right? And now we'll say we need to check. What do we need to check for? Multiples. Now, how do we check for multiples? The ideal way would be to have a list, right? Now, where should we have that list? Okay, so we could do it after the number is chosen. Let's put or create a list here, and we could use list comprehension to create that list. Okay, so we could say int of chosen number multiplied by x, or x in range 1, 12. We are going to continue one round only until the counter reaches the chosen number times 12, right? Therefore 1, 12. So we'll have those multiples there, right? And of course, we need to make sure that those brackets are closed, right? Now, do we pass this multiples to computer play? Remember, this would be required also by the user. Because multiples will not be available to this function, we can declare it as global and make it available. So here we can say global multiples. Once I do that, then this particular variable is available to all functions. Okay, I would recommend you declare globals at the top. Also, another point to note in Python is if, for example, this is going to change within another function, then it has to be declared as global there as well. Okay, but for multiples here, we are not going to be changing it. We don't need to declare that as global within another function. So now that that's available, we can check here, right? What do we check? If counter not in multiples, then we print my input, comma, counter, right? Else, if counter is in multiples, then we just print my input bus, right? And that completes the computer play. Now, the user has to enter, right? So how do we do that? We could do it here, or we could have a separate function. I'm going to do it here for now. I'll leave it to you if you want to have it separately. Okay, so here we'll say users turn or users input equal to input, right? So the user is going to enter something there. And then we can check if users input dot lower equal to bus, then we can call check bus. So this has to be brought to the right indentation. Control V. Right, and of course we need to send the user's input, right, and the counter as well. Now I have a question. We have counter equal to 0 here, but counter is being accessed in more than one function, right? So do we need to declare it as global? Yes, we do. Right, so global counter. Okay, so we are sending now the counter along with user's input to check bus. If the user does not enter bus, so here we'll say else, right, and then we can call this function. Control X and see that is positioned properly in terms of indentation. Okay. Now, remember that we have multiples only up to the number times 12, which means that these steps can continue or should continue only as long as counter is less than the number times 12. So here we put in another loop and we'll say while counter is less than int of chosen number, right, multiplied by 12, right? So again we have a loop, which means that all this should be indented appropriately, right? So I'm just going to do a Control X and then Control V, and of course make sure that all lines are properly indented. Okay, so now we have these two functions, right, that we need to put code into. So let's go to check bus first. What do we check here? So now remember, the user has typed in bus, and what is coming into this function? Remember, we are passing some parameters there. What are the parameters that we are passing in? User's input and counter. So what we can do is we can call them the num, right? And we can say count or counter. Okay, just not to use the Python reserved words. So now what do we do here? If counter, right, in multiples, the user has entered bus, which means that is correct. We can say print comma end equal to none. Right? Else, the user has typed in bus, but the counter is at a number which is not a multiple. So then we can just print, right? And here we can say str of counter plus, when I'm using concatenation, I need to convert the integer into a string, plus space there is not a multiple of space plus str of chosen number. Have we called it chosen number or have we called it something else? That's what we need to check. So it is chosen number. Now I'm using chosen number in this function and I'm also using chosen number here. I need to therefore declare it as global. So global chosen number. Now we need to put in code for the next function. Which one is that? This one. When the user enters any other number. Now what do we need to check there? Here we check if, and of course remember there will be parameters here. So let's call it num entered. That will be the user input and our counter again. So now if int of num entered is equal to counter and int of num entered is not in multiples. So what does this mean? The user has entered a number, right? It is right by the counter, okay, and it's not in multiples. Then the user is correct, right? So what do we say here? We say great, right? Now we have another condition. What if the number entered is the same as counter, but it is in multiples? What does that mean? It means that the user should have typed in buzz. So elif int of num entered is equal to counter and int of num entered in multiples. Then what should we say? We will print, right? That's the other condition. There's one more condition. What if the number entered by the user is not equal to counter, right? And the counter is in, or rather the number specified by counter is part of multiples, right? If that is the case, if int of num entered is not equal to counter and counter in multiples, then again we should say, right, else the number entered is just not equal to counter and of course counter is not in multiples, then we need to mention to the user that he or she should have set comma counter, right? We just got that number wrong, okay, and then return. Right? What's the next function we need to write? Wish to continue. We have a response equal to input, and then of course we need to return the response. Okay. Now, what if the user does not type in yes and does not type in no? How will the computer interpret it? So to take care of that, what we do is we say response equal to null, and then we have a loop while response. So what will happen here is if the response put in is neither yes nor no, then this loop will continue. Okay, of course we need to make sure now that our indentation is correct. As always, remember that Python is very strict on indentation. Right? So now we have that function done as well. Now this particular function, where should it be called? Should it be called within this while loop, which would happen every time there's a turn, or should it be done at the end of, or rather when this condition is no longer met? Right? That means counter is no longer less than 12 times the number we've chosen, right? So that is the exact point. So what we do is we will make sure that it is in line with this indentation. How do we do that? We just do Control X, come again there, right, and then Control V. So now you're in line with this while, which means after this loop is exited, right, after the while loop is exited, then we will come to wish to continue, right? Okay, so I hope this is clear. Deliberately, I have left some bugs in so that you will know how to tackle errors when you get them. So now I'm just going to run this and we'll see what happens. Okay, so gain of bus. We get our instructions. We know that this works already, so we don't need to check that out. Let's try a number. And now we get chose number is not defined. Where is that? Line 13. Now, if you want to see line numbers, click on options and click show line numbers. Go straight to the number and you can see that the spelling is wrong there. Right, so change that. Okay, and what I suggest you do is you run this in another shell. So when you have a clean slate, so to say. Or computer play takes 0 positional arguments but 1 was given. What's the meaning of this error? Okay, so here we have computer play is sending counter and here we don't have it. Right, so let's just say counter here. Or we can try not sending it at all. Why? Because we declared it as global. So let's run that now. So now what's the error? Local variable counter reference before assignment. Which line is this? 40. So now what does this tell us? When we are changing, remember we're changing the value here. And as I had mentioned earlier, when you're doing that, we need to specify global counter again. Okay, now run that. Try again. Now you get, it's my turn, my input 1, 2, and we have another error. What does it say here? Check other entry, missing 2 required positional arguments. Okay, which line number is that? Line 19. Where's line 19 here? We are not sending in the values. Which values are those? What the user has entered. So let's send that in. Let's say users input comma counter. Okay, let's run that now. Four, 2. Now you see the computer is saying 2 still, right? And it is saying you should have said 1. So something's going wrong here. Let's check. When it says your program is still running, kill it. Yes. So now what's going wrong with this? When we come back from this computer play, the value is 1, right? So after that, we should increase this, no? Counter plus equal to 1, right? So now let's run that and see if we have resolved that error. Four, 2, I input 3. So now we need to say buzz, right? 5, 6, 7. Let's not say buzz, let's say 8. You didn't say buzz. But the game is not over. It's going on and on. So again, let's kill this process. Why is it going on? Because right after it does this, where is control going? Back here. And then we're just going back into the loop. So we should be checking to see here, right, whether the game needs to end. How do we do that? We can have another variable. Let's call it end game. Okay. But end game, remember, is going to be accessed in this function and in this one. When game is over, we would have to assign a value so that we could check that value in this loop to see whether the game should end. And therefore we declare it as global. Okay, now where should we assign a value? So what we'll do here is, as long as the user wants to continue playing, so every time this loop starts again, end game will be assigned the value no, or it's not the end of the game, right? And then within this check other entry function, when we have a statement print game over, we say here end game equal to y. Only remember that now we're changing the value of end game. So within this function, we need to declare it as global again. Okay, so now what will happen? End game will be equal to y if the user has not said buzz, and this happens in 2 places here, right? Now we can check here if end game is equal to y, then we need to break out of this loop, right? We break out of this particular loop and this question will be asked, right? Let's now run this and see if that works. My input 1, 2, we have an error here. End game is not defined. Line 24. If end game is equal to y, what's the name of the variable? It's not underscore. Okay, let's just change it here as well. Okay, and now if we run that, four, two, bus, 6, let's type in 8 instead of bus. You didn't say bus, but it's still going on. Now why is that? Okay, so what could be the error? Here, as you can see, we don't have it mentioned as underscore, which means we also need to check the global entry here, right? And that too has not got an underscore. So you see how spelling errors can make a big difference in terms of marks. So let's say game of bus. Let's try that again. Bus 6, 8. You wish to continue playing. If I say yes, then I get choose a number, right? And so we continue. Let's try with another number. Let's say 3, right? It's your turn now. So we're saying buzz at the first instance. Why? Remember we said yes and counter is incrementing again, right? Without being reinitialized to 0. So what should we do? We have this instruction, right, taken off from there and put in here. Okay, so then every time counter will be initialized to 0. Right? Three. So that's 1 now. 2 bus. 4, 5. We've got to type in bus. 7, 8. That's correct. 10, 11. Bus. 13, 14. Bus. Right. 16. 17. Let's type in 17 again. You didn't say bus. Game over. Do you wish to continue? No. But now we're still continuing. Right? So what do we need to do? We need to say here reply equal to wish to continue. Right? Because remember we are saying return response. Where is that response going? It needs to be sent back somewhere. So that will go into reply and then it will go back and check. So if it is equal to yes, then it should continue. If it's equal to no, it should come out of this loop, right? And here we can then say print thanks for playing. See you again soon. Right? Say 3, 2, pass. So 4, 5 bus, 7, 8 bus, 10, 11 bus, 13, say 14 bus, right? 16 bus, 19, 20, right? And now we say 22, 23 bus, 26, right? 28 bus, 32, right? 34, 35, and we say bus. And it says 36 is not a multiple of 3. Okay, so we need to check that up, but let's see if we type in no now, if we get a message. Thanks for playing, see you again. Now, why is it saying 36 is not a multiple of 3? The simple reason is that here we are saying 1 to 12. Okay, so now what I'm going to do, I'm going to show you what's happening. We'll say for x in multiples, print x. Okay, so now let's run this and see what those multiples are. Say 3, and you see I'm only getting up to 33, and therefore to say 36 is not a multiple, right? All I need to do then is to increase this to 13. Now if I run it, and you see I have 36, so now I will not get that error, right? So this is how we work while coding. It's always an ongoing process. You will get errors, but you need to know how to tackle them. That's more important than avoiding errors in the first place, right? So this now ends our session for today. In the next session, we'll be talking about sets and dictionaries, and of course we'll do another project like this. Okay, so till then, take care, stay safe, bye.